You have the gift of being natural. That's a great talent, my boy. Oh, I hope the entire country was listening. The entire country.
Chapter 1. The Dawn of Electro-Horticulture. The applications of electricity to the stalks of plants. The use of electricity in horticulture, while seemingly of recent years, had its small beginnings long before the invention of the dynamo, and even antedated several years Franklin's important discovery in 1752, by which he startled the scientific world with the announcement that he had drawn the electric fluid from the clouds by means of a kite, and had proved it to be identical with the electricity of the Leyden jar. As early as 1746, the very year which saw the invention of the famous Leyden jar, von Mambre of Edinburgh began to study the effects of electricity upon plant life. His first experiment being with two young myrtle trees. He simply passed the current down through them to the soil, and found that it stimulated their growth. Soon, experimenters upon the continent were at work along the same lines, and their results were such that they readily agreed with him that electricity exerted a favorable influence upon vegetation. They, like von Mambre, passed the electricity, developed mainly by friction through the stalks of plants to the soil. The machines they used to develop the currents were so crude, and their experiments conducted upon such a small scale that but little advance was made upon the initial experiments, and the interest accordingly waned. In 1783, Abbot Bertholon became interested in the subject, and his investigations soon convinced him that electricity was decidedly useful in the maturing of plants. His enthusiasm reached a high pitch, and he gave vent to it in a book concerning electricity in plants. He devoted the larger part of it to reporting the results of his experiments, and the remainder of the description of the applications and the descriptions of the appliances used in furnishing electricity to the plants. We shall briefly describe two of these devices. One consisted of an insulated rod supported vertically, holding up some points in the air and terminating in other points directly over the plants. His intentions being to draw down some of the electricity in the atmosphere and pass it through the plant into the ground. The other was more ingenious and complicated,
That's a great talent,
and furnished electricity on a much larger scale. A barrel of water was placed on a cart. Beside it stood the operator on an insulated stool. His body was connected by means of an insulated wire with the positive pole of the frictional electric machine in action. As he dipped water out of the barrel by means of a large sprinkling can, it became charged with electricity from the machine. By sprinkling it upon the plants while the cart was being driven among them, the currents was delivered to them by the water and passed through them to the soil. These currents of high electromotive forces, pressure, generated by the frictional electric machines used by Bertholon, could readily pass through the water to the plants and through them to the ground. While Bertholon was observing the effects of devices which gave a much larger supply of electricity to plants than they could get from the atmosphere, Gardini of Turin was pursuing an opposite course by watching the results of experiments which entirely removed plants from the influence of the atmospheric electricity. The former claimed that by increasing the supply of electricity, he could markedly hasten the maturing of plants, and the latter that by depriving plants of it, he could very materially retard their growth.
You have the
Gardini's
gift of
method was
being
to protect
natural.
plants from the influence of the atmospheric electricity by covering them with cages of wire gauze, and then to compare them with others exposed to the action of the electricity in the atmosphere. The wired gauze, which surrounded the plants, conducted the atmospheric electricity away from them to the ground, and the result was that the plants drooped. When he removed the wire cages, they revived again. He gave his conclusions as follows. 1. The atmospheric electricity exerts considerable influence upon the production of vegetable matter. All things equal, plants will develop better everywhere where they are exposed to the action of atmospheric electricity. 2. Plants protected from the action of atmospheric electricity have, in the same space of time, given from 50 to 70% of fruit and seedless than the plants placed in ordinary conditions, that is to say, to which electricity has free access. 3. The proportion of albuminous substances does not appear to depend sensibly upon the influence of electricity, while plants that are protected from it appear to contain less water and more mineral substances. 4. Tall plants have a harmful influence upon the development of plants that grow at their base, not only by depriving them of light and heat, but also because they absorb atmospheric electricity at their expense. Leclerc, who was experimenting at the same time, agreed with Gardini. Sully tested the matter in another way. He planted 3 grains of corn in a flower pot and placed it under a bell glass. In another pot of the same size, filled with the same quality of earth, he planted 3 similar grains and placed the pot under a bell glass of the same size as the former one. He provided so that each would receive the same amount of water and air. Thus, both were protected from the influence of atmospheric electricity. He then arranged one of the bell glasses so that a wire passed through its top and ended in a number of radiating points just within. This wire was connected with an insulated metallic vessel near the bell glass, from which vessel issued a fine stream of water. The flow of water electrified the vessel, and the currents passed down the wire and was dispersed within the bell glass. Thus, one flower pot, with its embedded corn, received a constant supply of electricity, while the other received none. It was soon noticed that the plants in the electrified air were growing faster than the others. In 10 days, the former were 10 centimeters high, while the latter were but 8. These experiments were largely repeated and abundantly confirmed. Yet there were experiments who reported contradictory results. Among them was Egenhaus, a high authority in vegetable physiology in his time, 1787. His denial that electricity exerted a beneficial influence upon vegetation very much chilled the enthusiasm of those who were experimenting, but still the experiments were not discontinued. Especially interested and active became Mr. Selim Lemstrom of University of Helgensford, who had noticed that in Lapland and in Spitsbergen, plants grew with wonderful rapidity during the short polar summer, and their flowers were more brightly colored, and if they were cereals, yielded surprisingly large crops. He attributed this to the fact that atmospheric electricity was more abundant in the polar regions than elsewhere. He knew that these regions are the peculiar homes of the aurora borealis, a generally conceded electric phenomenon. Lemstrom planted seeds in pots and put some of them under a system of wires with points projecting downwards so as to deliver the electricity from the positive pole of the Holt's machine upon the growing plants. The others were not exposed to the current. He found in 6 weeks, the machine being in operation 5 hours each day, that the plants electrically treated were 40% in advance of the others. He also found that it did not matter whether the electricity was passed down through the plant or in the opposite direction. In 1885, experiments were conducted on a larger scale in the open fields in the domain of Nemes. A system of insulated wires was erected over part of a field of barley. At short intervals were metallic points which could deliver the electricity down upon the grain. The system was connected with a positive pole of 4-disc Holt's machine. The negative pole being connected with a zinc plate buried in the earth. The machine was run 8 hours a day. The result was that the crop was increased 1/3 in the electrified part of the field. Larger claims were made in the following year by the experimenters at Broadtorp, who used the currents from the 4 electric machines. From the many experiments conducted by Lemstrom, he concluded that electricity favorably affected the growth of wheat, rye, barley, oats, beets, parsnips, potatoes, radishes, celeries, leeks, kidney beans, raspberries, and strawberries, while carrots, rutabagas, turnips, cabbages, and tobacco were more or less injured by the electric treatment. That the results obtained by the different investigators were not always harmonious is not strange when we consider that the experiments were performed at various points on the Earth's surface, and that the time of day during which the current was applied and the length of the application were subject to wide variations.